Solve the following triangles. I start with the first case. By solving a triangle, we mean finding all of the angles and all of the sides. In problem number 1, the information which is given is as follows. AB is 4.2 centimeters, BC is 5.1 centimeters, and CA is 3.1 centimeters. We can see that the sides of this triangle are given, and these sides are different from each other. To draw a proper sketch of this triangle, I draw a triangle with 3 sides which are different from each other. The shortest side is 3.1 centimeters. The longest side is 5.1 centimeters, and the other side is 4.2 centimeters. AB is 4.2, therefore this would be AB, then BC is 5.1. Here is a sketch of the triangle that we are trying to solve. We can use the cosine law to find any of the angles in this triangle. I will find the angle A. Based on cosine law, I can write 5.1 squared is equal to 3.1 squared plus 4.2 squared minus 2 times 3.1 times 4.2 cosine of the angle A. I can solve this equation for cosine of A in the following way. I can bring all the numbers to the left to get 5.1 squared minus 3.1 squared minus 4.2 squared is equal to minus 2 times 3.1 times 4.2 cos of angle A. And I can divide both sides of the equation by this coefficient. I would have cos of A is equal to 5.1 squared minus 3.1 squared minus 4.2 squared divided by minus 2 times 3.1 times 4.2. If we use our calculators, we see that cos A becomes 1 over 21. Again, using the calculator, we see that the angle A is approximately equal to 87.3 degrees. Now let's show this result on the sketch that we had. 87.3 degrees. Now we can find the other angles by using the cosine law again, or we can now use the sine law because we have one of the angles. If I use the sine law, I can write sine of 87.3 degrees, that is the angle A, divided by A, which is 5.1, is equal to sine of the angle B divided by 3.1. We can cross multiply this equation to find that sine B is equal to 3.1 times sine 87.3 degrees divided by 5.1. We can use our calculators to get that this is approximately 0.607. This means that B is approximately equal to 37.4 degrees, or B is approximately 180 degrees minus 37.4 degrees, which is equal to 142.6 degrees. We should note that if we use our calculator, we get this result. But we know that if sine of an angle is a certain value, sine of 180 degrees minus that angle is also the same value. In other words, sine of any angle is equal to sine of 180 degrees minus the same angle. Therefore, our candidates could be both of these options at the moment, 37.4 degrees or 142.6 degrees. However, the second answer must be discarded. The reason is that if that answer is correct, let's look at the sketch again. If that answer is correct, we will have a problem. By looking at the sketch, we see that the angle B is facing the smallest side in this triangle. There are three sides, 3.1, 4.2, and 5.1. The side which is facing angle B is the smallest. As a result, angle B must also be the smallest. Therefore, it cannot be more than 87.3 degrees. We should choose the smaller answer, which was 37.4 degrees. Let's show that on the sketch of the triangle that we have. The third angle, which is angle C, can be found by considering that the sum of the angles in every triangle is 180 degrees. If we use that, we find that angle C is equal to (180 degrees minus 87.3 degrees, which is angle A, minus 37.4 degrees, which is angle B. If we use our calculators, we see that the angle C is approximately 55.3 degrees. This completes solving the triangle. Let's now look at the second question. Here is the information that we have about the triangle. The angle A is 45 degrees, side A is 16.3 centimeters, and side B is 19.4 centimeters. Now, in order to make a sketch of this triangle, I first draw the angle. 45 degrees would be almost this angle, and let's say this length. So this is angle A. The side facing this angle is also given, it is 16.3, and one of the other sides also is given. I assume this one to be in here. So I move from A by 19.4 centimeters. And I will reach point C. Because then 19.4 will be called B, which is the length AC, the length or the side facing angle B. And then I would have the other side as 16.3, which should be smaller than 19.4 here is a possible sketch of this triangle 16.3, which is in fact the length A. Even right here, I can see that there were two possibilities to draw CB. I could also draw, let's call this B prime, CB prime, and as we can see, CB prime and CB are both of the same length, 16.3. We can see right away that there are two triangles that I can sketch which would correspond to this information. Let's for now ignore the second sketch, so I'm going to remove it, and let's pretend we could not visualize both of the triangles. Let's see what information is given. We can see that two sides and an angle which is not between two sides are given. Immediately from this, we know that we are dealing with the ambiguous case, in which case we may have no solutions for the triangle, we may have one triangle, or we may even have two triangles. We always have one solution or no solutions, but when we are dealing with the ambiguous case, we should be expecting the possibility of two triangles, two solutions in general. However, in particular cases, it might be we don't get any solutions for the triangle because the numbers are not consistent. Let's now write down the sine law to find the angle B. Sine A divided by A is equal to sine B divided by B. We can cross multiply this equation and solve it to find sine B is approximately equal to 0.84, which implies that B is either 57.3 degrees approximately, or it is approximately equal to 180 degrees minus 57.3 degrees, which is 122.7 degrees. There are therefore two possibilities for the angle B. We now list the information that we have about these triangles. On the one hand, I have this candidate. Let's here list angles and here list sides. Angle A is 45 degrees, side A is 16.3, so I write down beside these numbers what they are, and then angle B could be 57.3 degrees and side B is 19.44 centimeters. So we are looking for angle C and side C. Once we find them, we can say we have solved the triangle. But there is also another possibility, that angles and sides, so the angles are, again, A is 45 degrees and the side A is 16.3. The angle B could be 122.7 degrees as we calculated, and side B is 19.4, and our purpose would be to find angle C and side C. Let's call this one case 1 and the other case 2. Let's now focus on case 1. We can easily find the angle C by using the fact that the sum of the angles in any triangle becomes 180 degrees. Therefore, we have angle C to be equal to 180 degrees minus 45 degrees minus 57.3 degrees, which is approximately 77.7 degrees. We can now use the sine law to find the side C. Sine of angle C divided by side C is equal to sine of the angle A divided by side A. We can cross multiply this equation, use our calculators, and we find that side C is approximately 22.5 centimeters. We can repeat the same procedure for case 2. The angle C is equal to 180 degrees minus 45 degrees minus 122.7 degrees, which is approximately 12.3 degrees. Now we can use the sine law to find the side C. Sine of angle C divided by side C is equal to sine of angle A divided by side A. If we cross multiply this equation and use our calculators, we see that in this case C is approximately equal to 4.9 centimeters. Let's now summarize our findings. There are two solutions which would correspond to the given information. Solution 1 is this triangle. Angles and sides 45 degrees, 16.3, 57.3 degrees, 19.4, 77.7 degrees, 22.5. And solution 2, which is this triangle. Angles, sides 45 degrees, 16.3 centimeters, 122.7 degrees, 19.4 centimeters, and 12.3 degrees, 4.9 centimeters.